Good afternoon, guys. I'm Yuhi.
And I'm Steve Saxa.
Our project is diving with sharks, so we are going to model a deep sea diving shark cage and test how it behaves when shark attacks it. Obviously, a deep sea diving shark cage is pretty important structure because we want to keep the people inside the shark cage to be safe, and we want to know what is the extreme of the shark cage. We want to know how much force can it withstand from the sharks. So here is our structure. It's a 7 by 7 by 10.2 feet cubic structure. We model it like this from a similar structure online. We use coarse mesh instead of fine mesh for our structure because we found the coarse mesh gives similar results as fine mesh, and it takes much less time for the solver to solve. Our structure is made by steels and has the maximum strength 58,000 psi. We use three different type of sharks to attack our shark cage: the hammerhead, the bull shark, and the great white. Here is a table. We can see hammerhead has smallest bite force and weight, bull shark has medium, and the great white has largest bite force and weight. For the max speed, the bull shark is slowest and the great white is fastest. We set our top surface to be fixed. This is just a simplification because in real life it is attached to the boat and can actually move a little bit, but we think this is accurate enough for our analysis. We have two forces pinching on each side represents the biting force, and we have a force at the front applied on those three beams represent the ramming force.
First, we have the hammerhead results. On the left is the cage right before breaking, so based upon the maximum stress the material can withstand. We modeled that first, and then on the right is the cage with the same bite force but with the ramming force maxed out, so assuming it was going the max velocity. We used the ramming force of 22,000 pounds as the max force, and then using that to calculate what velocity the shark could be going at. And then in the bottom there in the table, you can see that the percentage of the velocity that would be allowed, in other words, if the shark was going 60% or faster of its max speed when it hit the cage, it would break. And that breakage is in the right hand picture. Next is the bull shark. The bull shark has the same setup as the previous one. The cage, however, no longer will be breaking, and that is because the bull shark has a much smaller velocity and total weight. And as you can see in the bottom right, the percentage total velocity is nearly 100%, so this cage is safe to use with just bull sharks. Next, there's the great white, and as most of you know, the great white is much larger and faster than the other sharks. As you can see on the right, the cage is clearly breaking. It has a deformation of about 21 inches. And for it to do that, it would be going at full velocity. However, for it to break the cage at all, it would only have to be going at above 6% of its total velocity. So this cage is not very safe for great white sharks. Here we have a table showing all of our results. As you can see, the great white is much stronger than the other sharks and only has to go faster than 6% of its total possible velocity to already break the cage and possibly damage or injure the people inside of it. This is a video of the cage breaking due to that 22,000 pound max ramming force. Finally, we decided to do one last test where we had all three sharks attack the cage going at max velocity. On the back is the hammerhead, and the front right is the bull shark, and on the front left is the great white. As you can see, only the great white really causes any noticeable results, and this kind of goes along with our data and proves that the forces exerted by a shark that big are so much more that it overshadows every other shark that is attacking the cage.